Hi guys, this is Dr. Manjunath Chennapugod from Anveshana Academy, Bangalore, India. Dear students, in the previous video we discussed some numericals on Carnot cycle. Now I will move towards next important problem on Carnot cycle. Next numerical on Carnot engine, that is fourth numerical on Carnot engine. Okay, so now I will read the problem first. Consider a Carnot cycle operating between temperature T1 is equal to 500 Kelvin and T2 is equal to 300 Kelvin, producing 1 kilojoules of mechanical work per cycle. Find the heat transferred to the engine by the reservoir. This is the problem. So what actually the problem? The problem is related to Carnot engine or a Carnot cycle, and the Carnot cycle works between two temperatures, that is T1 is equal to 500 Kelvin, T2 is equal to 300 Kelvin, and it is going to produce 1 kilojoules of mechanical work per cycle. So if it's so, some amount of heat should be get rejected. That heat rejection we need to calculate here. Okay, so now for that what I have to do then? That means what? T1 means what? 500 Kelvin. That means when it comes to a Carnot engine, there is a hot source or heat source or heat reservoir, we can say. Then one engine will be there, that is HE engine, and one will be heat sink will be there, that we can call it as a preser or any waste heat sink we can call. Okay, so this source working at a temperature T1, the sink working at a temperature T2. The T1 he has given, that is 500 Kelvin. So therefore the T1 is equal to 500 Kelvin. The sink works at a temperature T2. The T2 is equal to 300 Kelvin he has given, that is shown here now, 300 Kelvin. So then work because of these two temperature, engine is going to produce some amount of work. That work produced is 1 W is equal to 1 kilojoules, that he has given in the problem itself. But dear students, is asking to calculate how much amount of heat is getting rejected into the sink when it is doing 1 kilojoules of work. That is the finding now. So for that what I have to do then? So first one, I need to follow some steps in sequence order. What is that? First one, what you have to do, you should know the definition of Carnot efficiency, because if you want to solve this problem we require Carnot efficiency. If we have the Carnot efficiency, if you know the Carnot efficiency, then we can easily calculate the amount of heat rejected into the sink by the engine. Okay, so for that purpose we should know the definition of Carnot efficiency or formula for the Carnot efficiency. That is what? 1 minus lower temperature divided by higher temperature. That's what is efficiency. Then wherever it is required, right, to calculate the Carnot efficiency, we need to record the temperature values wherever it is required. Now what is TL and TH, we need to substitute to calculate the Carnot efficiency. That's fine. Now calculate the efficiency. Once you substitute all the values, calculate the efficiency. Once you know the efficiency, that efficiency you can express in terms of ratio, and by doing rearranging the equations we can calculate the work done or heat rejection. That how it is, that I will show in next. I will show you. Okay, then sometimes after getting the Carnot efficiency, with help of that Carnot efficiency data and heat rejection and heat supplied, we can calculate the work done easily. Okay, later we can calculate the heat input also, the amount of heat supplied also we can calculate. Okay, so this we can do here. Now how to do that we can see here, dear students. Now first, T1 T2 you already noted. T1 is equal to 500 Kelvin, T2 is equal to 300 Kelvin. He has given answer temperatures in Kelvin itself. Please write down the answers in terms of Kelvin itself. Now so we know the definition of efficiency. What is that? Efficiency is equal to 1 minus TL minus TH, that is low temperature and high temperature. then efficiency will be 1 minus 0.6 is equal to 0.4. So that means what? 40%. That 40% I can express in terms of 2 by 5 also. The efficiency what I can do? 2 by 5, that is nothing but what? 40%. We have calculated the efficiency. Now with help of this efficiency I can easily calculate the work done. But work done he has already given in the problem itself. Now work done is equal to how much? That is capital W is equal to 1000 joules or 1000 joules or 1 kilojoules, that he has given 1 kilojoules, but I written it is in terms of joules. Okay, fine. Now once you know the work done, then you can calculate the heat supplied. Why? How it is? Because we know the efficiency. What is the efficiency? Efficiency is nothing but it's the ratio of work done to the heat supplied. So here Q1 act as a heat supplied. So therefore what I can do now? I can take Q1 is equal to okay, so Q1 is equal to, I will rearrange the sequence. Q1 is equal to W divided by neta or Carnot efficiency. Then substitute the values now. Q1 is equal to, what is W? W is joules, 1000 joules. Okay, 1000 joules divided by 2 by 5. What is the efficiency? Efficiency you express in terms of 2 by 5, or you can write it 0.4 itself. Now 1000 divided by 0.4, how much you will get? You will get it 2500 joules. That means what? Q1 is equal to 2500 joules, or Q1 is equal to 2.5 kilojoules. That much amount of heat you are supplying to the heat engine. Yes, you calculated the heat supplied to the engine. With the help of this data, heat supplied, I can calculate the heat rejection. How it is, that you can see here, dear students. Now we know already. What is that? According to first law of thermodynamics, we know already W is equal to what? Q1 minus Q2. So what I can do then? Q1 is equal to, what I can do? W, this Q, it will come to the left side, it becomes plus W. Q1 is equal to W plus Q2. So the same thing I have written it here now. Q1 is equal to W plus Q2. Now rearrange this equation, because what we require here now, we require to calculate the value of Q2. So how to write the equation now? Q2 is equal to Q1 minus W. What is Q1? You already calculated. What is W? You already, in the problem itself he has given. So therefore Q2 is equal to, the Q1 value is 2500 joules minus W is 1000, that is 1000 joules. So therefore what happens? 2500 minus 1000, it becomes 1500 joules. Or else you can express that heat rejection in terms of kilojoules also. Divide it by 1000, then what? How much you will get? 1.5 kilojoules. This is the amount of heat rejected to the sink actually. So 1500 joules or 1.5 kilojoules of heat is getting rejected into the cold reservoir or a sink. This is the simplest problem. Okay, so what all you did here now? You calculated the Carnot efficiency. To calculate the Carnot efficiency, what you required? One cold reservoir is required, one hot reservoir is required. It works at 500 Kelvin, it works at 300 Kelvin. With the help of this data, what you done? You calculated the Carnot efficiency, you calculated the work output. At the last, you calculated the heat transfer to the engine. One, that is Q1, as well as you have calculated the heat rejected from the engine also, you have calculated with the help of the Carnot efficiency. This is how the problem, this is how to solve the problem of Carnot cycle. Thank you. Dear students, please subscribe my channel. Do like, comment and say and support me. Thank you.